I'm Jeroen. I'm one of the early stage researchers within VPHCase, and I'm originally from the Netherlands, but at the moment I'm in France, in Lyon, where I'm connected to a company called ANSYS, as well as doing my PhD with Politecnico di Milano. The key features are that I've been able to collaborate with many different partners in Europe. Already I've moved to France, I've seen what research is like in a different country, and additionally I have partners to collaborate with in Italy, in the UK, in the Netherlands, and it's been a good experience to get that opportunity. My PhD is trying to address the feasibility of simulations for cardiovascular diseases. And by that I mean that simulations should be usable in a clinical setting. And at the moment this translation from the research area to the clinical setting has not been taking place so much. Patients would benefit from this kind of research because they would get access to better diagnosis methods, they would get access to better clinical planning tools, which have not been available in the past. So the main innovative part is that we can do simulations in real time. We've looked at multiple models and come up with a strategy that allows us to do real-time simulations, where before it was only possible to do these within the time span of a day, perhaps 2 days or 3 days. So for my research question, I'm mainly looking at in silico techniques. And for these in silico techniques, we're looking at mainly fluid dynamics models, structural mechanics models. And these are very traditional types of models, which have been used since perhaps the 80s. The new methods we are applying are reduced order modeling techniques. And in a sense, this makes a surrogate model of any of the modeling techniques beforehand. And this is what allows us to do these simulations in real time. In the end, we want to provide a toolbox that can incorporate all of the necessary features. And by necessary features, I mean we need to have cardiovascular models, which are based on fluid dynamics and structural mechanics, but need to be applied to a medical setting. So in this case, that means that they need to be applicable to patient-specific data, which means that we are looking at models from literature from medicine, from fluid dynamics and aeronautics, and of course for models for soft tissue mechanics. The collaborators on this project are Politecnico di Milano, which assists me in my PhD, and Terenva. And Terenva is a company that specializes in endovascular imaging. And what we are providing the methods to do simulation, while Terenva is providing a way of exposing it to the clinic.